So without any further delay, I'll let Josh to start presenting, and I'll mute myself.
Yeah, appreciate the intro. Thanks. I'm very good at drinking wine for sure. So yeah, I'm Josh Caplan. I'm a principal program manager on the Synapse team. I've been actually on this team for about since about February, and before that, I spent the last 6 years on the Power BI team, and you know, on the analysis services side of things, as well as the you know, data modeling pieces on Power BI and Premium, as well as actually the developer pieces on Power BI as well too. So I've been kind of all around that space, and now I'm on the Synapse team. So I want to talk today about how you can really build an end-to-end data solution. We know the data ends up visualized in Power BI, but starts out in a much different form. When you're building a platform that's going to work and serve hundreds or thousands of people, you know, how do you build that to scale with the same end result ending up in Power BI, visualizing that data? So if you're not familiar with Synapse, we announced public preview a few months back. We announced Synapse overall, I think back in Ignite last year. And you know, we've taken, there's this line here we say, well, simply put, Azure Synapse Analytics is SQL data warehouse evolved. And you know, what we've done is we've taken that same core, that base, that massively parallel SQL warehouse product that we had for the cloud. We've taken that, that's been our base. We've enhanced that core even further for faster performance, for more parallelization. But then we've also added other capabilities to it. You know, the big data capabilities that come as part of Spark, all the pipeline capabilities, and really everything you need to build an end-to-end solution in one product, which is now Synapse. So if you looked at our kind of reference architectures, and you look, you know, prior to the announcement of Synapse, and if you look at, you know, same architectures from our competitors, you know, you'll see that we always had all the pieces you needed, all the tools you needed to go build this end-to-end solution, you know, go from raw data to visualization. But we gave you the tools. You had to stitch them together yourself into an actual solution. So what we do now with Synapse, rather than giving you the tools and making you piece them together, we give you the solution. We've pieced together those all those components into one solution. So monitoring works universally across the whole thing. Security is applied across each component. You know, things like network security, VNets, set up once, works across all these different things. You're not setting them up for different components and trying to link them together. It's one product that has everything you need to go from that raw data to data visualization. So what does that look like? Now you have our different data stores like Azure Data Lake, and then you have Synapse, which can sit on top of that. When you link Synapse, what we call Workspace, that's the container that contains all your Synapse artifacts. When you link that to a Azure Data Lake store, you can immediately start analyzing that data without even any data movement. You can start querying it directly with SQL. You can start using Spark on top of that. If you do need to transform data and do data movement, we have all the pipeline capabilities of ADF built into the product. So you can ingest data, land it in SQL data storage if you want. You can transform it, do further analysis with Spark. And then all these analytic runtimes that we call them, which is basically the SQL engine or the Spark, the Apache Spark engine, they come in different form factors. For example, SQL you can actually get in a completely serverless fashion or an on-demand fashion where you don't pre-provision any compute, you're not paying for anything until you actually go and run a query, and then you kind of pay per terabyte scan of each query you run. And you don't have to worry about scaling it, having enough resources for things. It's just you pay per query and we worry about the resources for you. Versus the provisioned, where you can pick a certain amount of, you know, we call DWUs. That's kind of capacity that's reserved for you, and you can do whatever you want in that capacity. You can scale it up, scale it down, pause it, resume it, and run any number of queries on it, but you're kind of paying for that kind of reserved capacity. So they come in those two form factors. Right now, SQL is the only one that's offered in the on-demand fashion. But then Spark also has the provision mode and has the auto scale, auto pause and resume. with some nice capabilities there. And then on top of that, we support, obviously the T-SQL language, because we grew out of a SQL product here, but we also support all the different languages of Spark, including the .NET language on top of Spark as well. Now, all this is wrapped in one, like I said, workspace, which has all your management capabilities in there, your security capabilities in there, including network security. Monitoring is in one place. And this box here called Metastore essentially means that we have a unified metadata model across all these different features. So I create a table in SQL, I can use that table in Spark and vice versa. I can use that table with Spark. We're always in Synapse here. And then there's one tool, there's one development environment that sits on top of all this, and that's Synapse Studio, where you can do all these capabilities, develop on here, monitor on here, all on that single pane of glass within Synapse Studio. For things that are not core part of Synapse, we're doing a lot of work to make them feel like they are. So Azure ML, we're doing a deep integration with in Synapse. Power BI, we're doing a very deep integration. That's what we'll mostly talk about during this session. So other Azure services that contribute to this, even though they may not be part of the core Synapse product, they will feel like they are, and they will have these very deep integrations. So for example, if we look at Power BI, this is actually a screenshot of Synapse Studio. And in Synapse Studio, I can go ahead and not only build my data warehouse, build my pipelines, or use Spark notebooks, I can also go in the same screen, build Power BI reports in here as well. But the integrations we're doing with Power BI go well beyond just the UI. They go much deeper into the core of the product. These teams have been working together for a long time now, trying to integrate the two products at more than an engine level. We're constantly optimizing the types of queries that come from direct query and Power BI to make sure they run as fast as they possibly can on the Synapse engines, and vice versa. We'll sometimes ask for changes in direct query to get better performance when it runs queries against Synapse. We're deeply integrating the logging and monitoring pieces. So when you use Power BI against Synapse, you'll have kind of a unified view of the who ran what query, how did it perform, what did it take on the SQL side versus what did it take on the Power BI side. So you can do some more diagnosis and analysis there, and we're working also so you can use the best of both products together. So that very fast in-memory engine you get with Power BI versus the massively scaled and parallel performance you can get out of Synapse. How do we make the best of both in kind of a hybrid model? And we're also working to just speak the same languages too. So if you're using Power BI data flows, or you're using other products in Dynamics or Power Apps, the Common Data Service, we're all trying to speak the same language with the Common Data Model so that you can very easily do something, produce some data in one service and leverage it in another. So looking at the different features of Synapse, and I'm going to keep calling these features because these are not different products. Apache Spark can be considered its own product when it's done separately, but this is actually part of Synapse. It's a feature of Synapse, along with SQL. How do these features then benefit you as you're developing for Power BI? I mean, Synapse SQL gives you that very fast, interactive, query performance against really large amounts of data, and gives you a bunch of other capabilities to not only work with data directly over the lake, in a data lake, but also further optimize data, indexing, materialized views, caching, to really get the best performance you can get when going directly to the data. In kind of like a direct query model or even import. Now, Apache Spark extends those capabilities. It gives you that very heavy lifting capabilities you need if you're doing massive transformations, data movement. It also extends your analytic capabilities if you're going to do machine learning and other kind of predictive analytics. Again, it goes well beyond just BI here. There's many things you can do with data other than just the pure visualization, and those Spark capabilities extend to that as well. And Synapse pipelines. If you're familiar with Azure Data Factory, these are all the capabilities of Azure Data Factory now built directly into Synapse. So you can build those end-to-end workflows. Oops, someone project over me. Maybe project. Sure, my screen's back up now.
Yep.
Cool. So you can build those end-to-end orchestration pipelines with Synapse pipelines with Azure Data Factory basically built into Synapse. Gives you those high, we literally have everything in Synapse to do kind of high code data transformations to no code, low code data transformations, all within Synapse. And then Synapse Studio is that single pane of glass that binds all these together and lets you develop on one product. The Synapse Workspace is what literally is the glue between these pieces, so that I can log in once and I can use all these different capabilities, and I can monitor once across all these different capabilities in that one place. So I'm going to show a lot of this stuff today. Before I do that, let me just show where we are at today. So officially, Synapse is a GA product, because what we did, as I mentioned, is the evolution of SQL Data Warehouse. SQL Data Warehouse has been renamed to Azure Synapse Analytics. Those core SQL Data Warehouse features are, GA. If you had a SQL Data Warehouse before, it's now called Synapse. And there's a bunch of new there's a bunch of new features we announced as part of that rebranding that are also GA with Synapse today. And then there's some new preview features that are specific to that everybody gets, even if you're not on the official Synapse preview, that are really around the SQL capabilities. And then there is the public preview of Synapse, which is a whole new set of capabilities that are in addition to what you see on the left side here. And those are mostly what I'm going to show you today. If you're we're on SQL Data Warehouse before, yeah, you got the rebranding. You don't have these workspace capabilities that you see on the right here yet, unless you go and use the preview. Once all this stuff is GA, you'll be able to access this from your existing we now call Sql Pools, without having to upgrade or transfer anything over. It's all the same product. You'll have all the same capabilities if you were previously on SQL Data Warehouse. So go ahead and start with Synapse Studio here. So this is Synapse Studio. I've created a workspace for myself. You can actually go and create a workspace in just the Azure portal. It's a resource there. So when you go in the Azure portal and you create a new resource, you can search for Synapse Workspace and just create it. Workspace is pretty lightweight. There's no cost to actually creating one. You create it. You basically get a container for things that you can put in there. So one of the first things I did after I created it is I went and I linked to a couple data lakes that I have that already have data in it. So if I go over to my data tab here, I looked at my link sources here. I linked to several different storage accounts, and these storage accounts already have data. I didn't copy any data or move any data into my workspace. This data lives in my storage account. So I'm going to expand this one here. And I have the full data set for the New York City taxi cab on here. And not just the yellow cab data that we've used in other demos before, but all the the Ubers, the green cabs, all the for-hire vehicles you have. I even pulled in weather data, and I pulled in holiday data in here as well too. But all this is data sitting on my data lake in Parquet files. If you're familiar with Parquet files, it's a very popular columnar open source file format as used with big data. It is a very fast optimized column store data store. So I should go down to a month here. So highly compressed, like most column stores. This one's 545 megabytes compressed. I think it's about 100 million rows just in this one file. I haven't done anything other than create a workspace here to link it to that storage account. And I can immediately go and start writing SQL scripts against this. So we actually have a full SQL engine that can run normal T-SQL queries, the same stuff you're used to, directly on top of the data lake itself, either in files in Parquet, files in CSV, files in JSON. Parquet tends to be the most optimized because, like I said, it's a highly compressed column store. And I can immediately start writing queries in the language I know directly against that data. This was a cold read here, so no cache or anything. That came back 100 million rows, 21 seconds. Very simple select top 100 query. And I'm going against one specific file here. If you saw me navigating through that tree, there's a whole folder structure there with each one of those has other folders. Each one of those has different partitions of files. So I just queried one here. I think there's about 1.6 billion rows total here. I can do some more advanced queries directly on top of this data, again, without moving it. So actually, I pre-wrote some scripts, and they're in my workspace because this is where all my work is. So I can actually go over to our Develop Hub here, and I can find some of the scripts I've already written. This one's just a little bit more of an aggregate. It's a count and a sum and a group by on here. I could do joins if I wanted to. But one other major difference here is, if you look at the path from the last one, it was going to one specific file. This one, I've actually wildcarded the path. So I'm actually looking at every file in that directory. And all I did here is I just dumped that data into the lake. I didn't do any optimizations or anything here. It's just 1.6 billion rows across several different, dozens of Parquet files. And I'm running queries directly on top of that. And it should be here any second. There it goes. So 1.6 billion rows, no optimizations, and from a cold start here, I didn't have any kind of caching or anything going. I came back in about 37 seconds. Every time you touch a file, it's kind of considered a cold start, but once you touch the file, it's kind of warmed up and cached, and the more queries you run, the faster and faster it gets. But yeah, still a pretty good start for 1.6 billion rows there. Now I could just go ahead and take this query and immediately just drop it right into Power BI if I wanted to. And just do a new get data from SQL and just paste it in as like a native query. But some people might find this syntax a little hard if you're not used to the data lake itself or how the data is structured. And one of the nice things when working with a SQL database is you get that schema with you. So you can actually go into Power Query, connect to a SQL database, and it'll give you a visual way of constructing a query versus you having to write it by hand here. So even though I'm working against data in the lake, I don't have a real database here, I can still get that same capabilities of a real database in terms of of visualizing it. So I can actually kind of go ahead and create a virtual database here. So I'm going to pick my. Keep in mind too, I haven't actually provisioned any compute to do this. I'm doing this all through the on-demand service here. So I can actually go ahead in that on-demand service, go create a database called NYC Yellow. And again, this is normal SQL syntax. I'll flip back over to my data view here and refresh this. And now we see NYC Yellow here, and it's just an empty database. There's no storage allocated for it, so there's no place to actually load data to it. And we're not going to load data to it at this moment. We're going to just use the data still in the lake. So to make it easier for my users to actually go ahead and work with this data, I can actually hide all the complexity of the files and how they're stored in a view. So I'm just going to do a view here that's a select star from that same wildcarded file path that I used in the last query. And then I can just query directly against that view. Furthermore, if I actually, while that's running, if I go and refresh this, I see the view in my SQL database. And not only that, I see columns. I get actual schema here over data in a lake with data types. And this, if you go connect to this you can connect this like a normal SQL database in Power BI, and it'll look like a SQL database. You'll see the schema, and you can use Power Query direct against that to go construct a query. If you're going to use 1.6 billion rows and you're not going to optimize it very well, I wouldn't suggest direct query. Great for import for sure, but you can get very fast performance out of this as well too. Power BI, if you're in direct query mode and you're building a report, there's lots of good advice for direct query in general of how to design reports and design your data to get the best experience out of it. I'd say follow those same rules here. Yeah, because Power BI for direct query, you kind of want to be a couple seconds on average, and maybe in the very worst cases, you want your queries to run in like 10 seconds. But which you can get to if you optimize this a bunch more, or if you don't have 1.6 billion rows. But this is pretty good for just dumping data in there and starting from it. And it's really great for exploring data. So here it was, I queried the view. Like I said, we can go use this in Power BI. I'm going to show you one way you can go use this in Power BI just right from here before I conclude this demo. I showed you in the slide earlier that you can go and you can create a Power BI report directly in Synapse Studio. You do that first by linking to a Power BI workspace. So I'm going to go to my Manage tab for a minute here, and Link Service. I'm going to say a new link service. It does advertise Power BI to me right here. If it didn't, you could find it in the list here. But I'll go ahead and connect to Power BI. Call it Workspace. I should call it. It's new. Finding new things. Yeah, so I'm gonna pick. So basically, it did single sign-on to my Power BI tenant, and it's showing me all my workspaces that I have. I'm gonna pick the workspace I want to use here, which is the Synapse Power BI reports. And I'll say create. And when I say create, it's going to create a link server. So this is literally creating a connection to that workspace. That workspace I've already created in my Power BI. It's already got some reports and data sets in there. And as soon as I connect and I go back over to that Develop tab, now I have a new artifact in my tree here, and I see the workspace I linked. I can see the different data sets that are in that workspace. I have an option to go ahead and create new reports right here. I can also go ahead and create new data sets if I want to. We don't have the web authoring yet for Power BI data sets, so you have to do that in Power BI Desktop. But what we do have is you can say new data set here. And it'll let you pick from your existing let you pick from your existing Synapse databases, including that one we just made right now, that on-demand one. And if I pick this, it'll actually give you a Power BI data source file, which you can download. And when you open it, essentially will open the desktop pre-configured for this data source, and all you have to do is log in and pick the tables you want and build out your report. Oops, opened up another screen there, so but here, pull it over so you can see the yellow cap here, and the same schema would all be here. And then once you're done, you can upload this back to Power BI. You can upload it to your Power BI workspace. It'll automatically show up in here. You can start building new reports against it. And also, if you have existing reports, you can go ahead and start editing them in here as well too. Common question that everyone always asks after I show this: do I need premium for this? Answer is no. Like any Power BI license, when you're creating content, you need a pro license to actually create content, and you just need to be able to do this against a shared workspace. But other than that, you don't need premium. There's nothing premium specific about this. So that's that. Let me go back to the deck real quick. Well, I showed you here with SQL on Demand. And that lets you run SQL queries over files directly in ADLS Gen 2. Parquet files, CSV files, JSON files. Again, you can do it up front. You pay per query. You don't have to kind of pre-provision anything. When you're not using it, you're not being charged. It's a nice model. It's really good for that quick data exploration. So I just want to investigate what's inside a file. Well, might as well write some SQL queries against it. You can also do what I kind of did in the demo there, which is create this kind of logical data warehouse. It's not a physical data warehouse. You've kind of added SQL semantics on top of the data so it can be consumed by others. But you didn't actually persist any data or copy any data. You're just going directly against it in the lake. And then, yes, you can do data transformations with it. You can move, if you're familiar with CTAS and SQL, create table as, select. You can do CTAS with SQL on demand, and essentially select data from one file and output another file based on the output of that query. So some pretty neat stuff there. This is all part of the Synapse SQL offerings as part of Synapse. So commonly, there's that same T-SQL support and support for tools and the same security that's common across the different SQL offerings we have. But then there's also the provision mode, which was formerly the SQL Data Warehouse, which gives some additional capabilities. It gives you that SQL data storage format too, that columnar storage format as well. And that sits alongside with the SQL on demand capabilities as well too, directly over the lake. So let's talk Sql Pools for a minute. Sql Pools is that provision, is right now kind of synonymous with that provision mode. The lines will get a little bit blurred as we go on, and the same capabilities will be offered in our provision and a on-demand capacity. But today, if you have SQL Data Warehouse, it's now called Sql Pool, and that comes with it, the SQL storage. So when you insert into a table, it's saved in SQL's storage format. Then you also have DWUs, which is kind of pre-provisioned capacity that you can use to access that data. So the SQL Pools bring you some additional capabilities. They can further help you optimize performance, which we'll talk through some of these. It also brings with it stored procs, stored procs functions. And a few other interesting things we'll talk about as well too. So I mentioned that SQL storage format. That's the Sql Column Store tables. So you can have the data. We talked about Parquet before. This is the Sql Column Store, which again is highly optimized, but also has things like statistics. Start caching in there. You can have secondary indexes. You can combine row store and column store together. So you have all those extra capabilities in the SQL case. We also have certain capabilities in there like workload management. Since in this case you're getting resources, you're kind of pre-provisioning resources in the form of DWUs. You can allocate how those resources get used. So you can classify queries as they come in, maybe based on user. So you say, all right, anyone sending queries from the sales org, they can use 60% of my capacity. Anyone using it from the marketing org can use 40%. Synapse will manage that for you. And you can even change this on the fly if you want. Maybe sales has something important going on, you up their capacity, it can take effect immediately. And they can use more of the capacity that you've allocated. And we're going to so next what we'll do is we'll get some of that data from the lake. We'll put them into actual SQL Pools. One way of doing that is that we need to orchestrate some data transformations as part of that. Like I said, all that stuff is built into Synapse. With Synapse, we have those pipeline capabilities that are part of ADF built directly in, so you can do the orchestration for the data movements all within the same view. That can be, and those orchestrations can be triggered by scheduled or even events. As new data arrives, automatically kick off, start running those flows. We have the high code ways of doing data transformations, which I'll show you some of, but we also have some of the no code, low code ways. There's what we call mapping data flows, where you can kind of graphically go and construct your transformations. I don't know how many people knew this, but Power Query is also part of ADF. It's called a feature called wrangling data flows, where you actually open it up and you get the Power Query UI. This is currently only available in Azure Data Factory. It hasn't quite made it into Synapse yet, the Power Query piece of it, but it's in progress. So you'll see that pretty soon. But you have those same capabilities, that same familiar UI, in addition to the kind of the more activity-driven flow, the graphical flow that you get with mapping data flows. So let's build our data warehouse here. Let's take, I showed you some of the yellow cab data in the lake. Let's take some of that yellow cab data. Let's combine it with the Uber data, the holiday data, and all the other data I had, and let's make one kind of consolidated data warehouse here in SQL storage and SQL Pools. So flipping back to my Manage tab here, you can create SQL Pools by going over to the Manage tab. You can also do this from the Azure portal as well. That's also new. You basically go in here and say create new, and essentially, I'll show it from here actually, or I'm on early build. You can say new SQL pool, and essentially you can go and name your pool. One thing to note, the name of your pool is the name of your database when you view this in other SQL tools. So I named my first one primary SQL pool, which was not the most descriptive for taxi data. Pick your name, pick your size. Again, you can change this at any time. If you're working on, if you have an existing SQL data warehouse today, and you want to try the preview, but you don't want to try the preview on production, you can actually do a create from backup and point to your production one or the one you already have, and restore it to your workspace, and it'll basically create a copy of it within your Synapse workspace that you can work directly against, and that'll become a new pool. Once you have it, I created one called primary SQL pool here. It will show up in my list of databases, and I went ahead and did a couple things. First, I went ahead and created the schema. So I did this beforehand. So I just wrote some SQL scripts to go ahead and create the different tables I need in here. Now, what we want to do is we want to take these various different files. I want to load them to staging tables within the data warehouse, and then I want to do some kind of post-processing on that data, some transformations on it. So I can start out by doing a new pipeline here. And notice again, I'm doing all this stuff within one tool. So I want to basically copy that data from the lake then into the SQL tables. So I can just pull my copy task in here. I'll pick a source. My
Excuse me, sir. Can you please shut the fuck up?
Okay.
Okay. I'll find out who that is. We'll remove them from the meeting. Sorry for that, Josh. That's a new one.
So I can pick. I'm going to pick. Sorry, I'm going to pick Azure Data Lake Gen 2 because that's where my data is, and my data is in Parquet format. And since this is all done within Synapse, my already linked storage accounts already show up here, so I don't have to relink anything. I don't have to re-authenticate anything. I'll just pick Synapse Analytics. I can give this a name, and I can pick, the file that files that I want to do. So we were in here. We were in. And then I can pick the table I want to load it into. So let's pick it's going to be a SQL table in our Synapse Sql Pool. I'll pick my existing pool. Sorry. And I'll pick the table. We've made some couple changes here. All right. Well, imagine I picked my my table, the joys of dog fooding. So I picked basically the table in my SQL schema that I want to go load data into, basically the copy task would go and do that and load the data. But I said I want to do some transformations to it. So after the data is kind of loaded into that staging table in the data warehouse, I'm going to go and run some transformation. So I could do that in that no-code low-code fashion. So one way to do that is kind of pull in a new data flow here. And the new data flow, I can pick an existing one. I can say create a new one. And that data flow basically gives you that kind of graphical way of selecting columns, pivoting them, windowing them, joining them to other data sources, and kind of cleaning that data. You could also go and do it in a more high-code fashion. So I could write a Spark notebook here that does the transformations if you know Spark. I'm not the greatest with Spark, but I am pretty good with SQL. I went ahead and actually pre-created some of these. So in my database, I actually created some stored procs that do some transformations. So I go into programmability, look at my stored procs. And I created one, let's say, weather data maybe. I created a stored proc. Okay, that's kind of a weak one, but that goes ahead and does some of the post-processing, does some of the transformations, loads the data into the final fact table. Let me find something a little bit more interesting. Then I can use this in my pipeline. Again, since this is all one product, I can actually, just to get this into my pipeline, actually go ahead here and say add the pipeline. I'll pick the pipeline one that we're working on here, say add. I'll get rid of the data flow. And then all I have to do is say, okay, when this is done, kick off this stored proc, and I can do that just by linking the two. And I can do that for each source that I have that I want to pull into that data warehouse. So I actually kind of pre-did that too to save some time here. So I did one for the weather data, the yellow cab data, the green cab, the holiday data, the for hire vehicles, and for each of them I call a stored proc to do some additional transformations after that. So I went the more code approach, but you can go multiple ways here. And when you want to go and test this and run it, you can publish it and have it be triggered by a schedule or by some event. Let me show you that real quick. So if you do a new trigger, you can decide, is it a schedule? Is it based on some sort of window? Is it based on some sort of event, like new data arriving? I'm going to just do it I'm going to run it right now. And this will basically go and kick off. Again, notice I'm not logging into different, I don't have to go log into ADF. I don't have to authenticate that against my server. I just go and connect it and run it. Now, to monitor it, I also can do this within the same experience here. So it's running now. I can go over to our monitor hub, and I can see it's in progress. I can actually see which steps are in progress right now. This one succeeded. These are still running. This one succeeded, so now it's running this. And I actually go back. I can see actually one of mine failed earlier. I can go and see what exactly failed. All right, it was this step failed. Why did this fail? All right, let's dig into the reason. Oops. Dig into there it is. Sorry. And I basically have a data type mismatch in my destination table when I do the transformation. So the stored proc's returning that error. I can go fix a stored proc, and then I can go rerun this one step to make sure I've actually fixed the problem. So that is then going from the raw data source, and then building the pipeline, getting into the data warehouse. And I can go build Power BI reports against this. But let's talk about optimizing those Power BI reports, getting the best performance that you can get out of these. So any questions there before I go on? It's been mostly kind of silent.
Hi. Yep. Sorry, hi, it's me. Hi, I have a question. I am actually working on a really interesting Synapse Power BI project, and where we want to do composite models. And
I'm going to hold that thought for a second then. That's
Okay.
my next thing.
Great, then I will ask later.
All right.
Thanks.
Hey, Josh, I had a question about the managed identity in Synapse Studio compared to maybe an ADF, as I've run into some issues with that when using data flows.
Okay. If it's an issue type thing, do me a favor, shoot me an email afterwards and I can help trace it down for you.
All right, awesome. Thank you.
So let's talk optimizing performance for a second. We kind of really offer here multiple layers of caching. And I always tell people, if you're using Power BI, really nothing beats a small, well-optimized imported model in Power BI. And what they usually tell me is we're going to use direct query. So with direct query, if you're in pure direct query mode, there's no real optimization in there. There's no real caching on the Power BI side, but we have multiple layers just on the Synapse side as well too. And I'll call off a couple of them today that you can then leverage. Some of them will be leveraged for you automatically, and some of them you can further leverage on your own to get even better performance. So, direct query is going to be firing. There's no data stored in the Power BI model. It's always just firing queries off directly against the, in this case, the Synapse database. So the first one I'll talk about is Materialized Views. I'm not sure if everyone knows what Materialized Views are. Most people probably know what views are in SQL. You can create a kind of a logical view of data across multiple tables. Essentially, it's more of a SQL query. But in the Materialized View case, you add one more word to it, which is materialized. And not only will it just create a logical view of the on top of other SQL tables, it will actually materialize the data within those tables. And that will do a few things. Once it's materialized, anytime data changes in the underlying tables, that will be transactionally updated. When you can, let's say you did like an insert statement into one of the base tables that's used in your Materialized View. As part of the commit for that insert statement, it would be to update the data not just in the base table itself, but also in the Materialized View. So the data is constantly kept in sync between these kind of copies for you automatically without you having to manage it. The other thing that Materialized Views will do for you is if someone goes in and queries the base table, one of your fact tables that you built the view on top of, and if that query can then be leveraged by the Materialized View, which is usually a smaller, more aggregated form of the, or already kind of pre-computed form, SQL will automatically rewrite that query to go use the Materialized View instead. So as an example here, so this is a query I have written here. There's no Materialized Views in place. If you look at the execution plan for that query, you'll see lots of different joins, lots of different data movements across nodes in the data warehouse. And it's a much more complicated query plan. If I go and create just one Materialized View here, and then in the Materialized View, I'm already pre-joining some of the data, I'm pre-aggregating some of the data, pre-calculating some of the metrics. Like I said, this will be kind of materialized. Now I just go and I run that exact same query, and it will go. The query plan will look like this. It'll be much simpler. There'll be less joins, and then there'll also be less. You see data movement, data shuffling between the multi-nodes in the Sql Pool here. And you can get a lot faster results when you leverage Materialized Views. Now notice in the query, it's the same query. They didn't do anything different to try to leverage the Materialized View, which just kind of happens automatically. So Materialized Views you can go and create. They're there now. Like I said, queries will automatically leverage them. Result set caching is something that's also there now. You don't have to go and create these. These kind of get created automatically based off queries you write. We'll cache results of those queries, so if future queries come in and can use them, they'll use the cache instead of having to go back to the data source. And this can save a lot of time, but these are a little bit more volatile than materialized views, which will always be there if you create them. So those are some of the quick overview of some of the things you can do in Synapse to kind of layer performance in there. You can also do things on the Power BI side. Composite model was brought up. So composite model lets you mix kind of the best of both modes. So Power BI has 3 storage modes, and this all sits on top of what Synapse then offers. So Power BI has its in-memory mode where you have stuff fully in memory. You have direct query where stuff's fully not in memory, it's fully at the source. And then you have dual, which is kind of a mix where one table can be in both direct query and import. So what this means now in a composite model case, you can have a set of tables that's in direct query, a set of tables that's in import, and you used to have these in 2 separate models. Now you can combine them all into one model. That's the composite piece of this, and where you mix direct query and import together. Now, the feature that helps you a lot with performance on top of this is aggregations, which is another step on top of the composite model, where you can create, kind of like we created a materialized view in the SQL database. In Power BI directly, I can go create a aggregated table that could combine data from multiple tables. In this case, it's really just a summary of the data that was in the sales table, and it joins to the geography and date table, but doesn't join to some of these other. It doesn't join to products, so it's at a higher grain. So if a query comes in that's written, give me date and give me city for sum of sales, which is on this table, Power BI will actually rewrite the query. The white boxes here are actually direct query tables. So Power BI will actually rewrite the query to use the import table, the sales ag table, automatically. And it will never even make a call to Synapse. It'll just evaluate the query locally in memory inside Power BI. You'll get very fast results coming back. If I was to rewrite this query to ask for a customer, then what would happen would be it wouldn't be able to use the ag table because the ag table doesn't go to the granted customer. So it would go against, it would write a SQL query against Synapse in this case. Now notice in the last picture, date was blue and now it's white because date is actually a dual mode table, which can be found in both direct query and import. So when, when we were hitting all import, we used date as an import table. And then in this case, since we're going direct query, we use date as direct query table. So we remote everything to direct query versus trying to run the query in 2 places and stitch it together. This is kind of the most efficient way. So those dual mode tables can really help optimize perf there. Even if you're not even going to use ags and you're just going to have a full direct query model, it's great if you can put your dimensions in dual because it'll just help things like slicers and drop downs just be so much faster. Even if the ultimate query is going to run in direct query when you actually construct a visual. So one last demo. I have one other data set, which is if you've ever been to how-old.net, it was a big thing for a very brief period of time a few years back. You'd upload a photo to it, and it would analyze or detect all the faces in the photo, and it would try to tell you the age of the person and the gender. So it went viral for a brief period of time, and I still remember it. But so looking at some of the telemetry from that, every time you upload a photo, there was a row in the photo fact here. And then you can see different metrics by how it was submitted, what operating system was used, what browser was used, and when it happened. And then the photo fact goes into some detail around like there's a session ID, anonymized user ID, reverse IP lookup of where the thing was being done from. This is there's about 2 billion rows in this table. I created a photo fact ag table, which just takes some of this data and pre-summarizes it, so it's a lot faster. And this table's an import. These tables are all in dual mode. This table's in direct query mode. Once you create this ag table, you just have to associate it with the with the base tables. So like say if someone queries photo fact for a sum of face count, then you can actually use the face count column on the photo ag table instead. I just did this for a couple other things. You don't actually have to do it for dimensions as long as there's relationships. So we can discover the aggregation through relationships as well too. You just need to really worry about your measures mostly. So 2 some billion rows in here, import and direct query. Let me go back to Synapse, develop, and open up the report here. So open up the report here. There we go. So okay, I have some different visuals here, looking at photos by different browser, photos by different day of the week, by different submission method, photos over time. All of these are in the aggregation, so none of these are hitting the 2 billion row table directly in Synapse. So they're very fast, very interactive. Now, this is showing photos by day. If I want to drill into one specific day and see the photos by, well, minute or even every group of few seconds, I can actually drill down into this one. And now I don't have the minute granularity in the aggregation table. So this just ran a direct query. Now, every time I slice on here, it ran a cache and aggregate query, cache query here, in-memory query, so in-memory query here, in-memory query here, again, direct query here. Same thing, I click on this one, it'll be an in-memory query here, in-memory query here, direct query here. The nice thing about this is, I'm not flooding the database with every type of query. If queries can be answered by cache, I save the database, that extra heavy lifting it has to do, and I answer them very quickly from in the memory. And then the ones that really need that detailed data can actually go down to that database and running in direct query mode. If I do click on something here, it'll run all the visuals in direct query mode because it needs to filter those other visuals by the minute, which is not in the aggregation table. But it all happens for you transparently if you set up these ags correctly. And then there's further caching going on in the Synapse side as well too. One last thing I'll show. Scroll back up here. User count. So how many users submitted photos on a particular day? Now, if you ever do distinct counts, they can be time consuming. And distinct counts, you never really want to answer from an ag anyway, because in most cases, it probably won't help you much because you need that raw data there to really count those number of users. So I'm going to drill through here to my users page. And I'm going to calculate users in 2 different ways here. One is by doing a count distinct of user ID. And the other is doing an approximate count distinct. Both of these are direct query. But Synapse has a approximate distinct count function, which tries to determine the answer, the unique number of users, based on an algorithm called hyperlog. So it basically uses statistics to determine it. And they can actually get the answer using much less resources, much faster, within 2% accuracy of the final number. So you can see this came back a lot faster than distinct count did. And you see the numbers are very, very close. It's documented to be within 2%. This is one way you can leverage, do user counts or do any kind of distinct counts. If you don't need the exact number, you're okay with that 2% margin. Approximate distinct count is something that can be very, very fast. It is a documented DAX function, but it only works in direct query mode, so you may not notice it. But if you type in, it's not in the actual DAX parser in Power BI Desktop, but if you type in approximate distinct count instead of distinct count, it will actually work for direct query mode and call the right functions when it goes out to SQL in Synapse. All right. So I didn't save much time for questions, but I'm happy to hang on a little bit longer and go through questions. There's things we want to talk about. that's basically all the prepared content I had. Are there any questions? I see one hand up. Oh. Sorry, James, you see something?
Just one question, Josh. Ian Stewart here from Altis. Can you hear me okay?
Yeah.
Great. So yeah, the joined up end-to-end functionality looks really, really good. Nice to see it. Previously, the barrier to Azure SQL data warehouse was generally cost for smaller organizations or that organizations with less data. So a lot of people just went for Azure SQL database. Is there any plans to make the same functionality available, or is the cost model change to make this more affordable for people with less data or smaller organizations?
Well, so we did introduce now the new cost model around the on-demand query price, which if you have small volumes of data and you're not just constantly hammering it, can be pretty cost effective for those volumes as well, for sure. We want Synapse to be the place to go for analytics. So we do have some things on the roadmap, particularly around SQL database when you're using SQL as like an operational data store. I don't know if you saw what we did recently with Cosmos DB. We announced something called Synapse Link, where you can then attach Synapse. You have your Cosmos DB database, and you can attach your Synapse to Cosmos DB. I link it like I was doing it to a data lake, and then you can use the Synapse functionality directly on top of Cosmos DB without having to duplicate that data or move it to SQL first, or move it to the data warehouse first. So we will have some things like that, so you can extend those capabilities of those existing databases.
Okay, thanks.
Mm-hmm.
Hello, it's Mihai. My question would be in terms of SQL. So I saw two things. One is for time intelligence. It seems to be that the queries that is run in direct query. I don't know if it's in Synapse. Is it specific to Synapse, or Power BI will run the same queries? Or is
You're talking about so if you're in Power BI and you use time intelligence over direct query, it may run multiple queries.
Yeah.
That is not specific to Synapse. There's a kind of a DAX fusion thing that well, in this case doesn't go on. And we try to combine. We try to do everything in as few queries or Power BI tries to do everything in as few queries as possible, and so you might have multiple measures in the same visual, and it tries to fuse them into one underlying query as best as possible. In the case of time intelligence, and especially with certain visuals, it sometimes doesn't do as a good a job. Phil Seamark has a great blog on this around how you can trick the optimizer into not doing that, and to do much less queries. And I know that's something the Power BI team is also looking at to do a little bit more automatically.
Yes. So one thing that I noticed is just kind of the simplest time intelligence, same period last year. It's generating, not like, year is 2018 or something, or it's actually generating 365 days of, casted and is in an in function, which is not that effective.
Not
but the other
most
thing
efficient.
is, yeah, not really.
Which is why I still say, I mean, you can get great performance out of direct query. There's a lot of videos and docs out there of how you can optimize for any data source. I would say continue to follow those rules. The composite model approach lets you get the best of both worlds. So a lot of times it's really expensive or time consuming to import. Well, if you only import an aggregate, it can be a lot faster. And most of the time, the queries can be answered by a small amount of data anyway. So if you use a combination of the both, you can sometimes get the best performance, especially per cost or per effort, really.
So just lastly, a quick question. So what I noticed that I have visuals that generate, 30 queries to complete, but it seems like the queries are actually executed consecutively. So it executes 6 queries, and then it waits, then it's another 6, and it's another 6, it's another 6. So individual queries are really quick, but I still have to wait for a lot of seconds until it actually renders. So is there any limitation in Synapse, or because I know we could?
It's the DAX formula engine is single threaded. Okay. So one DAX query will only run, can only do one operation at a time. So not only occupy one query. So if you run multiple DAX queries, they'll run in parallel. But if Power BI runs a single DAX query, or someone runs a single DAX query against Power BI will run the SQL query sequentially.
Okay, so it's for one visual, it will always be sequential. If
not necessarily one visual might still generate multiple DAX queries. Like sometimes the grand totals are a different query versus the rest of the visual. But in general, yeah, they might be sequential. That's a good reason why you want to look at that Phil Seymour blog on Fusion and see how you can reduce the number of queries.
Thank you. James, there was a few questions in the chat window, so if you would want to.
I'm just going through. So there's a question about what version of Power BI runs in Synapse. I think noted that it didn't appear to be necessarily the same version that runs in the Power BI service with older icons.
Oh yeah. It depending on which Power BI service you're looking at. They haven't released so basically you're using the embedding API. So the same ones you would use in Power BI Embedded are the same ones you do if you use the kind of the SAS embed. They haven't actually updated the visuals there for Power BI Embedded yet, which will hopefully be soon.
Cool, thanks.
But it is the same. I mean, it just looks a little different. It's still the same code base, same everything. It's just the styles are different.
Great. I think I've covered all the questions. Have I missed any, Prathi? Oh, no, one more just come in. Will multiple Power BI workspaces become available to link to Synapse?
Yeah, so some PM decided it was a good idea to make it one-to-one. That was me. We are going to reverse that. So we'll let you do multiple. I kind of had this grand vision that, oh, well, you'll have we'll have one Synapse workspace and one Power BI workspace, and they'll work like they're just the same workspace together. But reality is people want to organize data differently in Power BI versus Synapse, so we'll open that up.
So just going back to the question on the version of the Power BI, I think you mentioned about the icons look old. That's fine, but it's the same as embed. As the Power BI features come every month, how often this will get updated as the Power BI new service comes? Will it be in sync with the Power BI service release, or how will
it is the Power BI service? We're just embedding the Power BI service. If you were to embed the Power BI service in your own application, it would look the same. It's just it's a feature of embedding that's missing at the moment to show the new look. But it's literally the same service, same code, same everything.
Awesome, thank you.
Great. I think we're probably at the end of the questions. And firstly, Josh, a huge apology for the interruptions in the middle of that. Apologies to everybody. Thank you for persevering and getting through it. You did a fantastic job of looking completely unrattled and and ignoring them. So thank you for that. Hopefully that won't happen again. At least we know now how to deal with it if it does. So yeah, thanks for that, and apologies to you and everybody else. And thanks for doing a fantastic session. It's probably been one of the most popular we've had since we've gone virtual. So yeah, really thanks to you for getting up early in the morning for doing it, and for everybody all around the world. I think we've hit nearly every continent in the attendees, so that's really great.
I appreciate you both setting this up, and let me know if there's any other content you want to drill into.
Well, I think you're either my internet's gone or Prathi's Prathi's sound's not working. Yeah, we can't hear you, Prathi. Never mind. It's a good job she says thank you. I think good job I'm closing up then. So thanks again, Josh. Just for everybody's benefit, the session has been recorded, and assuming that Josh is happy for us to share it, we will post it up on our YouTube site. give me a few days. I'm off on holiday for a week, so as soon as I get back, I'll post that up on our YouTube site. We've actually finally got enough subscribers to get our own channel name now, so there's a bit of a more friendly link to get to it. And next month, we welcome Casper de Jong back to the user group, who will be doing quite an exciting session on composite models in Power BI, which is a feature which isn't even available yet in private preview. So this may be a world preview, assuming Casper gets to go ahead to be able to present it. So we're very excited to see that one. So thank you, everybody, and we look forward to seeing you next month.
Thank you.